Hello, this is question 5 from the 2013 MAT. We define the digit sum of a non-negative integer to be the sum of its digits. That makes sense. For example, the digit sum of 123 is 1 plus 2 plus 3 is 6. Fair enough. How many positive integers less than 100 have a digit sum equal to 8? Well, there can't be that many of them, so let's just write them out. We've got 8, 17, 26, 35, we've got a pretty clear pattern going on here. 44, we're going to end up reversing these, aren't we? So we'll have 53, 62, 71 and 80. So that's what, 9. So yeah, they're going in pairs, and then we might get an extra one if it's going to be an even number. Yeah, if it was an odd number, we wouldn't get that extra one. We just have a straight set of pairs. Okay, right, anyway, that's the first bit. Let n be a positive integer with n less than 10. So a single digit positive integer. How many positive integers less than 100 have digit sum equal to n? They haven't asked for an explanation. They just want the number. So maybe go for a pattern spot in it or something. So how are we building these up? If we were going to start from 1, so for 1 we'd have 0, 1 and 10. So they just come in a straight pair. It's an odd number, so we don't get a middle one. Because for 2, we'd have a 0, 2 and a 20 as a pair. But then we'd have an 11 as well, which doesn't reflect over. It really is looking like it's going to be an extra 1 each time, doesn't it? And then for 3, we'd have 0, 3 and 30. We'd have 12 and 21, and we wouldn't get a duplicate digit one. So it is just going to be n plus 1. They haven't asked for an explanation. I suppose you could build something around these explanations here, these pairs, but they haven't asked us to do it. Maybe it'll come up later on. How many positive integers less than 1,000 have a digit sum equal to n? Okay. Right, more pattern spotting is going to be required on this. Let's change colour so I don't get mixed up. So if we were doing 1, so we'd have our 0, 1 and our 10, then we'd have 100, which is just 1 reversed. We're not going to have anything else because that 1's now been taken when we get up to 100 or above. So that's all we're going to have. Then for 2, so we've got our 0, 2, our 20, our 11, and then we'll have, what we're going to have? We're going to have 101. We'll have 110. And are we going to get anything else? No, we're not, are we? Because you have to have a 1 at the start, and then there's only those places you can put the 1s. Aha, right, this, yeah. Right, okay, so by the time we've set aside that 1 at the start there, then we're going to get the result for 0, 1, because we've taken 1 off. So how many positive integers less than 1,000 have a digit sum equal to n? Right, so how are we going to actually figure out what's going on? Because we're going to get n plus 1 in the first 100, then we're going to get n, then we're going to get n minus 1. We're knocking 1 off each time. Then n minus 2, because if we've got, say we were doing 3, we'd have then the 30, we'd have our 12 and our 21, and then we'll be going into all of the answers for 2 in the next bit with a 1 in front. So we'd have a 102 and a 120, and we'd have a 111. And then when we get to 2, we'd have all the answers with 1. So we'd have 201 and 210. Right, so there's a group of 4, group of 3, group of 2. So we're doing this, which is, so we're adding up numbers. These are it's going to be a triangular number then, isn't it? Because we're getting 1 less each time. These are going to be triangular. Well, triangle will be going that way, so they've got the biggest number at the top. So we're going to have, we want to do the n plus 1 triangular number. So that's n plus 1 times n plus 2 over 2, which is all we want, isn't it? How many positive? Yeah, so that is our answer to part 3. Okay, good bit of pattern spotting again. Part 4. How many positive integers between 500 and 999 have a digit sum equal to 8. Right, well, we can do this because we're gonna, the 5 has already taken 500, so the 5's taken 5 of the 8 away. So that means we've got 5 and then whatever we get for 3, and then we got 6 and whatever we get for 2, 7 whatever we get for 1, and then 8 whatever we get. Well, we got that 800 one, which we need to add on the end. So we're going to have then, so that's going to be 4 plus 3 plus 2 plus 1. Yeah, because we're doing n plus 1 each time. So that means 10. We've got 10 positive integers. Yeah. Okay, that fell out quite nicely from, it's just doing this bit, but we've just taken the end of the sequence. Okay, how many positive integers less than 1,000 have a digit sum equal to 8 and one digit at least 5? Oh my word, right, well we've certainly got all of those ones. So how do we work this out then? Because if we got it in the 400s, then that can't work, can it? Because you wouldn't be able to get anything up to 5. Then in the 300s, we could do 350 or 305. In the 200s, we could do, so these would be adding up to 6 with a 5 in it. So we'd have a 3, 5 and a 2, 5, 3. We'd have a 2, oh no, that's too much, adding up to 6. So 2, 5, 1. Yeah, and a 2, 1, 5. And then, well, we got a 6, 2, 6. There's got to be a way of doing this, which isn't just going through these options, isn't it? 2, 0, 6. Because we're going to have, and we got a lot here. I mean, these ones, we got 8 of them just in this first block. So we got 8 there. What is the pattern on this? There must be a pattern. 5, 1, because we couldn't go any lower than these, could we? Because you just wouldn't have the, so we got 2, we got 4, get the feeling we're going to have a 6 and then an 8. So if we were in 100, they got to have things that then add up to 7 with at least a 5 in. So we could have a 1, 6, a 2, 5. We can, oh, and a 7, a 0, 7. And then flip those 6, 1, 1, 5, 2, 1, 7, 0. So that gives us 6, a 2, a 4, a 6, and an 8, which is 20. So it would give 30 overall. How do I know I haven't missed one? How do I know I haven't missed one on this? So, well, it's 3 lots of this. Makes me think that that has led us towards this bit of the question. So this is saying that you've got positive integers between 500 and 999 with a digit sum equal to 8. Yeah, I don't really know. Well, I'm happy that it's 30, but I feel as though there should be some kind of pattern there that I maybe should have spotted. So maybe there's going to be, right, okay. So this is what this is telling us, that there are 10 permutations where the first digit is greater than equal to 5, which is what we want, isn't it? So there must be the same number where the middle digit is greater than or equal to 5, or that the final digit is greater than or equal to 5. Yeah, that must be what it is. Yeah, we got a symmetry there. So I haven't missed any out then coming up with that 30. But yeah, we've got that symmetry. These digits are completely interchangeable. So yeah, whatever counts for 1 will count for all of them. We got 10 for the first digit, so it must be the same for the middle digit, and it must be the same for the last digit. Right, okay. I just didn't see that initially, but 30 comes up okay. So that's that bit. What is the total of the digit sums of the integers from 0 to 999 inclusive? Right. So what's that going to be? So we're going all the way up to, again, this must be another symmetry thing. That's what they've led us to on this. So we're going for, what are we saying for each digit then? Well, all digits from 0 to 9 will appear the same number of times in each one of the spots. So we're going to have then, so what does that mean? We've got 100 times each digit appearing in each spot. Is that too many? Would that be right? So how many zeros would we have in the first spot? We're going to go from 0 up to 99. Then we're going to have 100 ones, 100 twos, 100 threes. Yeah, so it will go up that way. And then in each block of 10, we're going to go through all the digits, and we're going to do that 100 times. And in the middle, yeah, so we're going to have each one. So each digit will be 0 to 10, 0 to 9, can't be 10, can it? 0 to 9, 100 times. So 0 to 9 added up, the sum of 0 to 9 is 45. And we're doing that 100 times for each digit. So that will then be 300 times that. So 300 times that is going to be 135 times 100, so 1,350. That's not enough zeros, is it? 135 times 100, 13,500. Yeah, that's better. So yeah, that works out okay, doesn't it? Okay, right. So yeah, they did lead us there on that last bit with doing that symmetry. You can see how they built it up from one bit to the next on that. It might have actually been easier to spot if they'd done part 6 before part 5. Part 6 is sort of pointing maybe a little more towards having that, oh yeah, all the digit spots are the same and we're going through everything. Maybe that would have been an easier way to pick it out. I don't know, maybe not. Well, I like that question. That was yeah, interesting. They didn't want any explanations on there. They just wanted the final answer for each one of them, which is yeah, probably handy, because a lot of these would have been quite hard to explain as to why they come out with the number that they actually do. It was just really pattern spotting, particularly for the first half. Once you start getting into the symmetry stuff on the second half, maybe an explanation would be a bit easier. Anyway, there you go, question 5.